Hi guys, welcome to lesson 24-2, solving equations by using logarithms, day 2. This one is going to be about application problems or word problems. So you will want your lesson 24-2, day 2 note sheet that's posted on Google Classroom. Again, you'll want your Desmos log calculator or your graphing calculator, and you'll want a pen or a pencil. Today what we're going to be doing is solving exponential word problems using logarithms. Okay, so here is your first formula. This is going to be really important, so I would make sure you write this down. But it says here, compound interest is interest that is earned or paid not only on the principal, but also on previously accumulated interest. So it's basically interest on interest. Here's your compound interest formula. Like I said, A equals P times 1 plus R over N to the NT. So in this case, A represents the amount in the account. P represents the principal invested, or like the initial amount, is usually what I like to call it. So P is the initial, A is the final amount in the account. So you have that, and then you have R, which is the annual interest rate as a decimal. So R is for rate, makes sense. N is for the number of times per year that interest is compounded. So if it's monthly, your N would be 12. If it's quarterly, your N would be 4. If it's daily, your N would be 365 because it's how often the interest will be compounded. And then T is the time, number of years. Okay, so let's try an example here. It says, and again, there's your formula and all of what it represents. So number 1 says you invest $3,500 in a bank account that has a 4% annual interest rate. Calculate the amount you will have in 5 years if the interest rate is compounded, A, quarterly, B, monthly. So first thing here, let's kind of highlight some important pieces of information. So we have $3,500 in a bank account. Its interest rate is going to be 4%, and it's going to be in there for 5 years. Okay, so those are key pieces of information, and then also this here, quarterly. So let's go ahead and fill those in now. So we have, you invest $3,500. That is your initial amount, so that is going to be your P value, $3,500. Then you have 4% interest rate, but remember that has to be as a decimal, so we need to move that 2 places, so 0.04. Then your T is the 5 years. That's how long it's going to be in the account. And then quarterly. So how many? Quarterly would be 4 times within a year. Okay, so A is what we're looking for, okay, because it says calculate the amount you will have. So that's going to be your final amount. That is what we're looking for. And that is your A. Okay, so now we're going to plug that into our formula. So we have A equals, so your P comes first. So 3,500 times 1 plus your rate, which is 0.04, over N, which is 4, to the N times T, so 4 times 5, or to the 20th, okay? So you can just literally plug that into your calculator as is. So I would do 3,500 times 1 plus, and then here's where I would do a little fraction, so alpha y equals, enter, and I would do 0.04, the rate, over the quarterly, so 4 times, and then to the N times T, so N times 5. And I'm going to plug it in just like that, and there's my answer, $4,270, and we're going to round to 2 decimal places because we're talking about money, so 0.665 would be 0.67. And we're, again, talking about money. So that was 427067. Beautiful. And that would be your final answer. So after 5 years, you will go from $3,500 in your bank account to $4,270.67 with that 4% interest rate. Okay. Now, let's look at the difference with monthly. Okay, so still not much is going to change here. You still have your $3,500. You still have your rate, which is 0.04. You still have your time, which is 5 years. So all that stuff we highlighted is still the same. And we're still looking for the amount you will have. But now monthly, obviously there are 12 months, so that's going to happen 12 times. So now we just need to change that N value. So the 3,500 stays the same. The 1 plus your rate stays the same. Now this is where it's going to change. So this should be 12, the N value, and then 12 times your T, which is 5. Okay, so again, I'm just plugging into this formula here. And the only thing that should have changed was the N values. So those 2 spots. Okay, and again, you're going to plug that into your calculator. So I'm even just going to press second enter. And I'm going to change those 4s for the quarterly to be 12. It's too far. 12. And press enter. And so now you can see you would make a little bit more, about $3 more, 4,273.488. So we're going to say 0.49. So 4273.49. A equals 4,273.49. And that would be your final answer there. So the more your interest is compounded, the more you're going to make. So here, like I said, about $3 more. Okay. All right. Then here are 2 more examples that you could go ahead and pause the video and try. So daily and semi-annually. So daily would mean your N value is going to change to 365. And that means each day it's being compounded of the year. And then semi-annually, that means twice a year. So that N value would change to 2. Okay, so go ahead and pause the video. And hopefully you paused and you tried both of these. And really all that should have changed is the N values again. So 365 for daily and 2 for semi-annually. And so you can see your new answers here. So daily, you would make even a little bit more than monthly because it's being compounded more often. But semi-annually, you would make a little bit less because that's happening just twice a year. Okay. But all very similar, probably within $10 of each other. Okay. All right, so that's our first type of formula. That is when it is compounded quarterly, semi-annually, daily, whatever the case might be. But there's also a type of compounded interest that is continuously, and you really will have to look for that word because it's a new formula. And this is your other one that you will need. This A equals P times E, so we know E already is that mathematical constant, to the RT. Sometimes I like to refer to this as the APERT, okay? So continuously is interest that is earned or paid not only on the principal, but also on previously accumulated interest continuously and not at a fixed number of times per year. So basically, there's just no N value anymore, okay, which there were in the last 4 examples we did. Okay, so now you have A, which is still your final amount. You have P, which is still your initial. You have R, which is still your rate, and T, which is still your time number of years. Okay, so let's try one of these. It says here you invested $2,000 in a bank account that has 5% annual interest. So we're just highlighting important pieces of information. Compounded continuously. As soon as you see that word, you know you're using your APERT formula. And then it says, how much will you have in 5 years? Be careful, they didn't use a number there. Okay, So as soon as it says how much will you have, we know that's our question mark, our final amount. 2,000 was the initial amount we put in. The rate is 5%, which we're going to move to make it a decimal, so 0.05. And then the time is 5 years. So we're going to plug that in. A equals P, which is 2,000, times E to the R, which is 0.05, times T, which is 5. And again, because we're looking for the A, these should go pretty quickly. You're just plugging it into your calculator. So we have 2,000 times E to the 0.05 times 5. So 2,000 times, remember your E is the second ln button, and then to the 0.05 times 5. And so it should look like that, and press enter, and there's your answer. So $2,568.05. And there you go. Okay. So these are pretty quick when you just have to plug the information into the formula. Okay. So I want you guys to go ahead and try this one. Pause the video here. And hopefully you're realizing that 3,500 is your P, 0.08 is your R, and then your T is 10 years. So you should plug in, and you should be getting that in 10 years after it is compounded continuously. 3,500, 8%, 10 years. You're just plugging all that in. You should get $7,789.39. Okay. All right, so we have one final type of problem that we're going to do, and these get a little bit harder. It's when you're trying to solve for the time. Okay. So in this case, it says right away how long. So because it says how long, we know T is our question mark. And then it says, would it take an investment of $7,000? So that's your initial, so P, to earn 3,000. So if 7,000 earns 3,000, you add those together, so your final would be 10,000. Okay, so maybe, no, you have to add those for your final. Interest if it invested in a savings account that pays 4.19. So that's our last piece there. We got to move it 2 places. So 0.0419. And again, compounded continuously. So we know we're using a PERT. So we're going to plug in what we know. And we've got 10,000 is our A. Our P is 7,000. Then we have the E. And then to the RT, so 0.0419 T. Okay, so here's the tricky part, is we no longer can just plug and chug in our calculator. So the first thing you're going to do is you are going to divide by this number out front of the E. So we're going to divide by 7,000 on both sides. Okay, and you're going to need your calculator for this as well. And so go ahead, we're going to clear all this out. 10,000 divided by 7,000. And you should get 1.4286, we'll call it. We're going to round to 4 decimals. So 1.4286. And that's your first step. Then this is gone. And this is still e to the 0.0419 t. Okay. Then what you need to do is you need to actually flip-flop these, because we can't convert the way it is right now. So we're going to flip-flop these so that it's just 0.0419t equals 1.4286. Now we can convert. So we're going to do that. And remember, when you convert with this e, it's going to be a natural logarithm, base e, of 1.4286. So that's what you're going to be plugging into your calculator. And then it equals 0.0419t. Okay, so we're going to plug this part into our calculator. So natural log of 1.4286. So natural log 1.4286 equals, and you get 0.35669, so 0.3567. And still set it equal to 0.0419 t. And then to get t by itself, because remember, that's what we're solving for here. We're solving for time in years. We're going to have to divide by this 0.0419, 0.0419. And that'll cancel to leave us with t equals, and now let's go ahead and do that in our calculator. So we have 0.3567 divided by what was that again? 0.0419. 0.0419, and we get 8.513, but we're talking about years, so let's just round it to one decimal place here. And let's say 8.5 years. Okay, so this one, like I said, a little bit more complicated, but you can still handle it. It's all things we know how to do. You're plugging in what you know. Then you're solving an exponential equation using logarithms, which we've done. Okay, so on this next page, I want you guys to try one just like it. So it says how long. So again, that's what you know. You're trying to find your t, time in years. Would it take an investment of 5,000 to double? So 5,000 would be your initial. To double, that would mean 10,000 is your final. And then 3.75 is your interest rate. So that would be 0.0375. And then, continuously. So you know you're using your APERT. So try that one out, walk through the steps, pause the video here. All right. So I kind of walked you guys through what info you should have. You plug it in. The first thing you should do is divide by that 5,000 on both sides. That's going to go ahead and cancel here and leave you with 10,000 divided by 5,000 is 2. And then e to the 0.0375, the rate, times t. Again, you need to flip-flop those so you can convert it to a log. This is going to convert to a natural logarithm. And then you're going to plug the left side into your calculator, and you should get 0.06931. And you're going to divide by the 0.0375 and get an answer of the time would be 18.5 years. Okay, so we'll do some more practice with this in class. If you have any questions, I know sometimes word problems get a little confusing, so please, if you have any questions, leave them here or bring them to class tomorrow. Thank you. Bye-bye.